Hey, g'day, it's Prezzo. Thanks for stopping by. This is part 2 of building a rear tool holder for a Colchester student lathe. Now I'm building this specifically for a parting off tool, and it's going to allow me to actually have that parting tool mounted permanently on the lathe. So in certain situations you can do facing operations and then immediately follow up with a parting tool operation without having to swap out any tools. Now I'm going to make a playlist about this build because it's going to go over several episodes, but let's have a close look at the bench now and see what we're going to do today on this build. This is where I got to in the first episode of this build. So this started off as a big circular disc of malleable iron. I've machined off the 4 sides. This is exactly the same width as the cross slide on the Colchester, and these 4 mounting bolt holes fit the pattern of holes in the back of the cross slide. So the next step is to machine a slot, or actually a T-slot in this part. Here it is here on the mock-up that I made. Now unfortunately I don't have a T-slot cutter, all I have is a Woodruff cutter. And this is an Imperial Woodruff cutter. It's 1 inch diameter here, 1/2 inch in the shank. And unfortunately that's not exactly the same as what I'd done on the drawings. So it doesn't quite reach the wall of the T-slot. But at the end of the day, these were just arbitrary measurements, so it doesn't really matter as long as I've got a T-slot in there. So I'll use that cutter, and I want to use TouchDRO to hit these 2 scribe lines here. Now there's a function in TouchDRO now, this is in the new version of the app, that allows you to set guidelines and then a cutter radius compensation, so you can hit those guidelines in the app. But these scribe lines here are just to verify that I'm doing the right thing. Okay, let's head over to the milling machine, set this up and have a look at the app. I've got that block centered in the bias there now, so I've used an edge finder and I'm lined up exactly over the center of the block. Now what I want to do first is just to hog out most of this material. So this is a 12mm carbide end mill. This is the one that I sharpened, the one that I broke the edge off. And I'm going to take down the slot to 22mm deep. And then when we got most of the material gone, I'll do the cutter radius compensation in the TouchDRO app to get these 2 scribe lines and hit the edges of the T-slot. I just did 4 passes at 5mm deep each, and the last pass now is going to be 2mm deep, and then we're going to start opening up that slot to its full width. So that cutter's doing really well, given that I abused it and broke it. It's cutting really nicely. So this was our target depth here, 22. Oh yeah, I overshot it. Doesn't matter because I'll probably trim the bottom of the T-slot anyway, just in the center. But this is the bit we're interested in here. So this is the cutter radius compensation where you can set up the diameter of your cutter. So we'll go to there, and we're using a 12mm diameter cutter. And we're going to set the radius compensation. Now nothing happens yet in Y, so we're still zeroed out in Y, which is the center of the slot. But what we can do now is we can go to another screen, a workspace, and we can set up some guidelines. So we do that up here. So here's our cutter, that red circle right in the middle there. And what we can do now is we can set two guidelines horizontally, one above, one below, which correspond to sort of like Y negative, Y positive. So to do that, just touch anywhere on the screen. So we're going to set a position of 9 millimeters either side of center. So we're going to add that there. So the first one is horizontal and 9. And we add the guide. Now you may not be able to see this on the screen, but there's a very faint red line there just above the center of the cutter. So we're going to do the same thing now, but we're going to do it in the other direction. So just hold, and we're going to put in this time -9, horizontal, add guide. So now we've got the two red lines there. Let me just zoom in so you can see them. So what we can do now is visually you can see where the edges of the slot need to be and how far we need to move the cutter. But you can also actually tell DRO to give you the radius compensation so you know when you're going to hit the line. So to do that, we're going to turn on a button up here. Alright, so now if I tap one of these lines and highlight it, we can get the position and get it to read down to 0 degrees when we're right on that red line with the edge of the cutter. So if I do that now, we'll just hit this one here. Now it becomes brighter, and over here on the side you can see I need to move the cutter 3 millimeters to hit that line. So what I'm going to do now is I'm going to take a series of like 1 millimeter wide cuts until we're close to the line, and then we're going to use that radius compensation to actually hit the line exactly, and then we'll measure it and see how close we got. So I've just enlarged that slot by 2 millimeters, and this was the last pass that I did here. And I'm doing conventional milling, so I'll go over the other side now and we'll do the next pass also at 1 millimeter. So just tap that line there. Whoops. Cancel that. If you press and hold, it'll actually delete the line, which I don't want. So it's just one tap. Okay, so it shows that I'm 4 millimeters away from that edge because I enlarged the slot by 2. So I want to go to 1. Alright, and we'll do another conventional milling pass, and that'll bring us over to within 1 millimeter of that line. That last pass has taken us to within 1 millimeter of our ideal width of 18 millimeters. So it should be 16 at the moment. So let's just see how close we are. And don't forget, this is a conventional milling pass, so we'll be pulling into the stock a bit. 1605 that way. (1605), yeah. That's sort of like what I expected, because with the conventional milling cut, the cutter will deflect into the work. I'm going to take 2 more passes at about 0.6 each, and then we'll do a climb pass to finish. Alright, that was the last climb pass. That should be 18 millimeters. Just let me find a way of measuring that accurately and we'll check. Okay, this is the best I could come up with, so I've just put an adjustable parallel in there, and we're going to measure that with the mic, and we're shooting for 18, and we've got 18.02. And just in case you're wondering, I haven't stolen Joe Piezinski's micrometer. I loaned these micrometers to my son when he was doing his apprenticeship, so that's James. And James engraved his name on all of them. So they're mine now, but yeah, that's where the JP comes from. Anyway, 18.02, I'll take that. That's less than a thou. This is a location feature. It doesn't need to be a precision fit, and I can machine the tenon that goes in there to suit. So what we're going to do now is we'll do the undercut to make the T-slot, and we'll see how that goes. I've got this top surface of the cutter 10 millimeters below the top of the stock, and it's centered on the slot at the moment. Now I can afford to come over 2.6 millimeters without hitting the shank of the tool. That's going to give us enough engagement for the T-slot. That'll be fine. So we'll try that and see how we go. So 2.6 is there. Now, I've never used one of these woodruff cutters in this way before, so I'm just going to take it really slowly. We're basically cutting full depth, and then we've got to go down to the bottom of the T-slot and do a second pass. I just stopped there. That sounded a bit chattery. I checked the speed chart and it says for a 1-inch slot drill it's 267 RPM in cast iron. This one's running at about 500 RPM because I've reasoned that it's got more than 2 teeth or 2 cutting edges, but I don't know. I think I'm going to slow that down. I'll put it in back gear and run at a much slower RPM. That turned out better than I thought. I'm running that now at 200 RPM, seems to be happy with that. So I'm going to lower down now and come to the floor of the slot that I did first, and then we'll just do the other 2 passes to finish up. I don't know if you can see it, but just on the bottom of the shank of the woodruff cutter there's a bright patch. That means that the shank was actually rubbing on the wall at the top of the T-slot. I probably should have stayed back a 1/10 of a millimeter or so from that edge, but I can't see any mark in the cast iron. Looks pretty good. So the next step is we're going to put a big chamfer on the 2 long edges of the block. It's got a big single insert chamfer tool here, and I've offset 47 millimeters either side of center. I've just touched off there. I'm just going to do like a bevel or a chamfer until it looks about right. It's really cosmetic, so it doesn't really matter what the depth of it is. So when I've done this side and I'm happy with it, I'll just zero out the DRO and Z, and then just come to the other side and do the same thing there. Alright, apart from deburring, that's finished, so I'll take it out and have a closer look. I've deburred all of that. It's going to need a more thorough going over later. But this dimension across the top of the T-slot was when I was trying to measure while it was in the milling machine. Now it's on the bench, I've got a better chance of doing that. And it's come out at 18.01. So on TouchDRO I was shooting for 18, and I don't know, like a hundredth of a millimetre. That's great for me, I'm super happy with that. So the 3D printed part can fit into the T-slot there now. And just off camera, because it's just plain milling work, I made a T-nut that can slide in the T-slot there. And I also went ahead and I just machined up this block. So this was just a rough piece of steel before. Now once again, it's just plain milling work. So this is all now to size. And I was lucky actually, it had two machined faces that were already square to each other. And that's because it came out of a much bigger block of steel that was an accurate part for another machine. So that saved me a lot of work getting those two faces already square. So that's going to go on top there, and you may be wondering, why have I got two? Well, it turns out I cut up the stock for this job over a year ago, and my friend of mine had the big bandsaw down at his place, and I went down there one day and I just cut up some steel. And I had some drawings at the time, but I don't know if you do this, but I went back and looked at the drawings, looked at the design, and I made minor changes to it, the things I didn't think would make a big difference. But it turns out the overall height of this block was too short. So I went and cut another one, and that's it there. So this is the same dimensions as the drawing now, so I don't need to make any changes. Just about to rough out the tenon on the underside of this riser or tool holder, if you like, tool block. And I've scribed some lines on there just to give me a visual reference. And the other thing about having a mock-up like this one here is that you can put the mock-up against the part that you're about to mill, and you can check that the features are in the right place. And that's important with this part because a lot of the features aren't symmetrical with the faces and the edges. And because you're turning the part and flipping it, there's every chance that, in my case, I'll screw up, put a feature in the wrong face. So this is just a visual check for me. And on TouchDRO, I've set some guidelines for the center, 0, 0, and the two edges of the tenon. But I'm just going to rough this out, and then we'll come back and we'll have another look at TouchDRO and how I'm going to use that with the cutter radius compensation to get my edges. Got to turn the camera on. It didn't miss much. I was just sort of taking off most of the stock. I'm at almost full depth, and I've got about, 4 mil to go on this side and about 8 on this side here. So what I'm going to do now is I'm just going to take like 1 millimeter wide cuts until I reach the edge of the tenon, and then we'll clean up the bottom here and take off the last little bit to finish up. So let me bring you over and show you what we're doing on TouchDRO, and we'll go from there. I brought the cutter back to Y0, and this is the point that I set as my origin. This is where we're going to drill the 12mm diameter hole through for the bolt that holds us down to the solid tool post. So I actually got 3 guidelines set up. I got one right through Y0, I've got one at Y9, one at Y-9. So if I want to machine this edge of the tenon, the top line, all I need to do is touch that. Okay, and then I can move the cutter across and set the radius compensation so I can hit the outside edge of that line. So to do that, we just tap where the cutter is, and we say we want to go to that position there, and then we can drive the cutter across. And as I come back, you'll see that in Y, this will change to 0. So when we get to that point, we're going to be right on the edge of the tenon. And of course I can do the same thing for this bottom line here as well. So that's the plan. I'm just going to machine back to the line, say 1 millimeter at a time until we hit that edge, and then I'll come across to do the other one. According to TouchDRO, we're 0.2 of a millimetre off full depth for the tenon, and the same 0.2 of a millimetre off both edges of the tenon. And what I'll need to do now is take a couple of climb passes along both sides and try and get this tenon to be a really good snug fit in the T-slot I've already made. Just let me check that, and then we'll take those last couple of passes. So this should be 18.4. It's actually 18.33. So what I'll do is climb pass on this side, and we'll bring it back to 0 according to the DRO, and then we'll come over on the other side and we'll just fine tune it. So now we're 18.18. I'll come to this side here now, and we'll do a couple of climb passes and try and hit that 18 right on the money. All right, the DRO said I was going to be 0.06 oversize, and that's pretty much exactly what we've got. So I'll do a climb pass on this side here, and I'm going to try and hit 18. Now, according to my measurements, the T-slot is 18.01 wide, so that should give us the fit we're looking for. Okay, moment of truth. Oh man. That's pretty good. So all I need to do now is go down to my full depth, and we're done. Actually, this measurement's not critical, but I'll take it down to exactly 6. Yeah, super happy with that. Okay, that's cleaned up to full depth. The width is right, so I'm going to come back to the 0 position, and we're going to drill a 12mm hole all the way through. That's all we need to do on that face of the part. I'm going to take it out and deburr it, see how good we got that. And this is the first time I've used coolant on this milling machine, and I remember now why I hate using coolant. It goes everywhere. It's all over me, it's all over the machine. Drilling especially is a pain, because these big shavings get caught and just flick the coolant everywhere. But on that really deep hole, it probably was important to not overheat the drill. I went ahead and deburred all of those edges. I fixed up this hole here, that's where the drill bit broke through. So I just countersunk that. And remember, what we're after here is a really good snug fit in that T-slot. So there's our T-nut, and it's a slightly loose fit. and let's see how good we got that tenon. I think it goes that way. So it just drops in, but it gets marginally tighter toward the bottom. Now we can put our M12 screw in there now, tighten that down, and that pulls it down the rest of the way. Now ideally, when you slacken off that screw, you should be able to slide that block by hand, but I can't. It's just a fraction tight. I can sort of break it free with a mallet and slide it, so probably need to do some dressing on that tenon or on the T-slot later on, but for the moment I'm super happy that that's come out as tight as it has. So what I was after here was to make sure that there was no chance that that block could rotate, and that ensures that the parting tool blade is always dead perpendicular to the axis of the lathe. But the fit in there is excellent. So totally happy with that. I can now trust my DRO again. So I basically did all of that just following the position on the DRO. Just about to cut the pocket for the tool holder, and this is another reason why having a mock-up is a good idea. It just gives you some visual confirmation that you're not about to do something stupid. So I'll cut that pocket, and I think I'll drill and tap the 3 set screw holes, and then we'll call it quits because this part will then be done. Oh, got to do the chamfers too. That's all the machining on this part done now. I've given this sort of a preliminary clean-up, but it's going to need a lot more work to get rid of all of the machining marks in it. But all the machining is done now, and we can put the 3D printed mock-up of the tool holder in position now, and that's held down with 3 M6 socket head grub screws in the top there. And when we come back in the next episode, we're going to machine that part from this lump of steel here. So I've just roughly marked out the overall dimensions of that, and we'll just rough that out in the milling machine. I'll do that off camera. And then inside the tool holder itself, there's quite a long slot that needs to be machined in there. And that's to allow this top section to clamp down and grip the tool. And there's also a couple of features in here to allow for the profile of this tool. So this is one of those T-type tools. Its cutting edge is wider than the body of the tool, and that means it doesn't rub and doesn't produce a lot of heat, and it's a bit more tolerant to misalignment. So that's going to go in there like that, and it'll get clamped down with its own socket head screws on top there. Now that's all in the next episode. Run out of time today, so join me for that, and yeah, we'll see if this thing actually performs like it's supposed to do. Okay, it's Prezzo signing up for now. I'll check you on the next episode. Cheers.